Hello, this is Affan Ahmad Khan, and you are seeing my YouTube channel. Today, I will discuss about the CAD designing of a hip implant. Actually, this is made by Solidworks. You can see the Solidworks interface here. This is design modeler, and the planes are shown here: front plane and origin, right plane. All this is. So this is the CAD design part. This is not assembly. This is made in one, you can say, one step, or in one file, in one part file. So this is my project of computational biomechanics, in which mechanical engineering and biomechanical engineering comes in play, so that we can combine the concept from both of engineering to make such implant, orthopedic implant, for the use of patients. So this is mainly made up of three component. This is called ball. This is femoral stem, the whole length of femoral stem you can see here, and this is cup, you can say, cup to insert the inside the hip bone. So why this is called femoral stem? Because this will go inside femur bone, or you can say thigh bone, the longest bone in human body. Furthermore, this is, I previously said, this is ball made up of biomaterial, which I will discuss in a minute. So this will insert in hip implant, in hip. The surgeon remove the bone, or any other surgery, or some part of bone will remove, and this will insert hip. This femoral stem will insert in femur bone, in thigh bone, and this will fix inside human body. Actually, this implant is for patient whose hip are damaged, and this will fix their problem by supplying structural stability and flexural stiffness. You can see there are uh, not corners, they are not sharp edges, they have been rounded with some radius to avoid the stress concentration, and the stress concentration, and you can see the singularity effect, another name. So I have also simulate this part. For the simulation, one must know about the material used in medical bioengineering for the implant, hip implant, knee implant, and other type of implant, total knee replacement, partial knee replacement. 316 low carbon stainless steel is one of the choice, and cobalt chromium alloy is also a choice, but the best choice is titanium alloy, especially commercially pure titanium and Ti6Al4Av. Best biomaterial, best properties of osseointegration and long-term stability is its flexural stiffness, its geometrical stiffness, and structural ability to withstand the apply load of human body. You can say, you have already know in the medical engineering field that human knee supported 6 to 4 times of weight. If your weight is 100 kg or 900 newton, during stair climbing or certain sport activities, your knee will bear 6 to 7 times of your weight. So this implant must be designed in geometrical way and material way to withstand the highest load during certain physical activity like stair climbing. So biomaterial is one of the crucial element of designing orthopedic implant in computational biomechanics or medical engineering or bioengineering. So you can contact me. My email is AFFANNED399 @gmail.com, or also you can contact for this model for this CAD design and simulation +92 324 2639 275. Thank you so much. I am here to help you.